Please welcome to the Explore Scientific stage, Mr. Ken Marts.
Hi friends, Kent Marts here from Explore Scientific.
We can hear you.
That's always a good thing. So off we go.
I didn't change a thing.
Had to restart the computer. That's what
and
you
then
changed.
Restart the software twice.
Yeah. So that's what you did. That's what it took. It's a computer. When in doubt, restart. So welcome to Amazon Live. Sorry about the false start a little while ago. We are going to be talking about First Light Chronicles, and let's start off by talking about some best practices, shall we? So best practices with a telescope are keep it clean. Don't leave it out in the weather. Take care of it. Treat it like it's a fine instrument, right? That's the first thing. Because it's investment, you want to take care of it. Our eyepieces come either with a First Light telescope. The eyepieces come in these plastic twist-up housings, like this 25 millimeter super Plossel, or we'll be talking about the Explore Scientific line of telescopes. And I've got a case here. Here we go, left over on the table. Or at least keep your eyepieces in a hard-sided carry case, a tackle box, toolbox, something. I use a toolbox, actually, a couple of toolboxes. Keep your eyepieces in the felt bags to protect them from the elements and from getting scuffed up and damaged. Always take care of your equipment. So the other thing is, you need to be aware of the weather. Don't leave them out, and don't let them get rained on. That's a critical component. Always learn to plan what you're going to do ahead of time. You know, sometimes you know what's up there because you're doing it a few nights in a row. But sometimes, like, you know, that's what we're going to look at tonight. And identify your targets, figure out where they are in the sky, and then be prepared to go out and look at them. Printing out some star charts to help you find them in the constellations is always good. Yes, Paul?
So one thing that I do know about telescopes, or at least with camera equipment, let's put it that way. Let's speak to what I actually 100% do know. You want to have your telescope or lens acclimate to the current weather conditions before you start looking.
Excellent point, Paul. Yeah, if you're inside of an air-conditioned house and it's real humid outside, that's just like if you take a cold can of soda or pour a glass of iced tea outside, that glass, that can is going to attract moisture out of the air and beat up and get really wet. So you want to be able to acclimate your telescope or your camera lens or your eyepieces to the temperature and the atmosphere they're going to use. And that means, you know, take them out, put them on the porch before the air conditioner gets going, all day long. Put them in a garage or a storage building that's not climate controlled. And that way you're going to help ensure that the glass just doesn't immediately fog up on you and you don't get a chance to use it. Now, you may still have some dew problems, especially on the eyepiece, because many of these telescopes come with dew shields that has a tube in front, 6 or 8 inches in front of the first piece of glass that really helps keep the dew from building up on the glass.
Let's see here. Yeah, our audio just dropped out on my end. We sound like robots now.
Oh, no. And I don't have a chat function up on the computer over here either. So,
I think.
So am I still up?
We're still up.
I'm going to keep going like we're still up.
Sound really crazy.
That's always a great way to, get your viewing started off on the right foot, is make sure you're acclimated. The other thing is, if your telescope is covered in dew, take it inside where it's going to dry off, or dry it off with a microfiber towel. Don't use the microfiber towel on your glass or your eyepieces, but carry it inside so the moisture can evaporate off of it. Don't just stick it into a carrying case, or if you keep a telescope in a plastic off of it, do not shove it in the wet, because that's going to create all sorts of other problems. And there's actually mildews and fungi that will start eating into the glass if there's moisture in the glass, and will destroy the lens coatings and actually literally eat into the glass and be perfect there. Is the sound still going haywire there, Paul? He's laughing. That's a bad sign. All right, so we're going to move along and talk about eyepieces. So the first thing we're going to look at is the 52-degree series of eyepieces. This is the same series of eyepieces that I've had before. They are our least expensive eyepieces right now. And they're in a 52 degree of apparent field, which means if you hold up the eyepiece and measured the distance
I got mine
you
working
can
again.
see. Yours is
No,
mine,
it was an interface problem on my end. I had, I guess my interface crashed
okay.
for the audio interface so I can hear what's going on.
So that's important for you to hear what's going on so you anticipate. So 52 degree apparent field of view is how this degree coming out of right here, and that affects the actual field of view you have in the telescope. Probably ought to do that, a segment on that. It's fairly simple math. Eyepieces come with numbers on them. Well, actually, first let's talk about eyepieces. Generally come in two sizes of eyepieces. They are 2-inch across and 1.25 inches across. So these are the 2-inch eyepieces, inch across, 1.25 inches across, 2 inches. So that sets us up. You need to make sure you know which telescope your eyepiece takes. Most of our First Light series only take 1.25 inch eyepieces, but we do have some 2-inch eyepieces. They tend to be the ones with the biggest numbers on them. Those biggest numbers actually determine the magnification of your telescope. Hey, Noah, can you get the chat function up for me, please? And maybe swing it over here so I can see it. Thank you. It comes up with a number on it. Every eyepiece has a number. This has a 40. That means it's a 40 millimeter eyepiece. People who are starting out in telescopes don't understand the math, and so they're going to want the widest, they may know they want the least magnification possible, but they pick the 4.5 or the 5 or the 7.5 or whatever. Well, the effect of it is that's the highest, that's super magnification because it's focal length divided by the number on the eyepiece. So if it's, we'll say 1,000 millimeter focal length, and this is 40, 40 will go into 1,000, well, make it easy. 40 will go into 100, 2.5 times, add a 0, that's 225 power at this point, okay? The 20 millimeter would, on the same telescope, 20 will go into 105 times, add the 0, that's 50 power. The 10 will go into 100 times, and to make it easy math, the 4.5, let's just round up to 5 millimeters and say it will go in 20 times into 100 or 200 times into 1,000. So you have 200 power. That's how you determine the power you have. Hey, Noah, can you swing that monitor over here so I can see it without having to really swing my head over? We have a chat function up here on Amazon Live. If you want to give us a shout out or say hey to us, that's great, Noah. Thank you.
Or
say
call,
hey to us. We would really appreciate
Kent
that.
a nerd.
Sir?
You can call Kent a nerd.
You can call Kent the nerd. That's not a problem. You know,
don't you appreciate the geek and nerd?
Geek makes the world go round.
What about the nerds?
Absolutely. You're watching on the internet right now. That was made by a geek. You're watching on Amazon.com right now. Made by a geek. 100% geek.
What about
here.
nerds?
So, and nerd, I'm not nervous.
Nerds.
Oh, I thought you said nervous. So, a great starter set of eyepieces right here. The 52 degree set of eyepieces are our robust, same engineering as all of our Explore Scientific waterproof eyepieces.
These are waterproof?
They are waterproof, yes, sir, Paul.
We had it on sale a while back. We
still
had
do.
Some that weren't.
We still do have the Explore Scientific Bresser 70 degree series, not waterproof eyepieces. These are waterproof.
Less expensive.
Yeah, they're on sale right now. I don't know if they're in the carousel or not, but they're on sale. The 70 degree 30 is on sale for the rest of this week, if I remember correctly, for
might ask Noah.
Grand prize of $50. Quite, in fact, I've got one over here back here. Quite the deal. Comes in. This is the not waterproof, and actually, this is a 25.
That's a 2-inch.
2-inch. It looks exactly like the 30 millimeter. This is a 25. They're almost exactly duplicate as far as exterior look goes. And as you can see, it's got a 2-inch barrel
Down.
and not an 1.25-inch barrel.
Yeah.
Right there. It's got an 1.25-inch barrel. It is not waterproof. The way you can tell is, if you look at the waterproof eyepieces, they have a little spot on them somewhere right here where it says AR and a little green logo. That means they're purged with argon. That is not on here. So this is not a waterproof eyepiece. Great eyepiece nonetheless. Will really give you some fine service, and like anything else, take care of it, because it is an investment even at $50. So if you have any questions, give us a shout out or a question here on the chat function. And if you have not done so and we earn your business, please click that follow button, and that helps us be served up to more people here in the technology sector on Amazon.com/live, Amazon Live. So back to the eyepieces. They're waterproof, which means they're purged with argon. That forces out all the air, and with the air goes all the moisture, because argon is a inert, dry gas. It does not attract water, and so you have no air inside. So once they're sealed, they may fog up on the outside and attract moisture, but the inside stays nice, pristine, and dry and clean. That makes the eyepiece much better to use, because it's not going to fog up. Once an eyepiece fogs up inside, it can be done. Now, with a 70-degree eyepiece, it can fog up inside. The trick is, keep it wiped down with a microfiber cloth. Don't let that moisture build up and get real wet. We have a video at some point we can show you, probably not today, about how you can wash these eyepieces, and it's real simple. Distilled water, a drop of Dawn detergent, dunk the eyepiece in there, swirl it around, the waterproof eyepieces, swirl it around, then dip it into another bath of distilled water with no soap, get it rinsed off really well, and then spritz it, dry it off with a microfiber towel, and then spritz it, the glass surfaces and the body of it, with isopropyl alcohol. That drives off all the water, and the evaporation forces all that moisture off. And now you have a clean, dry, waterproof eyepiece. These are the 52-degree set. They come in other sizes. That makes
Pekka is saying hi to you.
Hello, Pekka. How are you? The camera guy also, the whole production gases like sulfur, oxygen-3, and H-alpha wavelengths. Absolutely. So what Pekka's talking about is sulfur 2, double ionized sulfur, triple ionized oxygen, and H-alpha wavelengths. Those are very narrow wavelengths of light that, hair in my mustache, a very narrow wavelength of light that allows you to do astrophotography even where there is bad light pollution. Pekka lives in Sweden and Stockholm, and he has pretty bad light pollution. And we're watching the video right now of Mike Hatch and Scott Roberts. Scott's the founder and president of the company. He is showing you right now how to dunk it in. Now he's spritzing it. I don't believe he used a rinse of distilled water. I mean, there's almost
it's distilled water in the sprayer.
Right. It's distilled. It's alcohol in the sprayer, isn't it? It's alcohol in the sprayer. I've always done it in a dip of distilled water afterwards to just sort of dilute off any soap. And now he's drying it off with canned air. Now, one word of caution with canned air: don't shake that canned air and move it around too much, because if you do, the propellant can come out, and then now you're going to have to clean it off all over again. Yeah. And that stuff can be very sticky, so you really don't want to do that. So there you go. That's how you clean your eyepieces, with one drop of Dawn detergent, distilled water, isopropyl alcohol, and a can of air, and a microfiber cloth to help clean it off. Keeping your eyepieces clean. You don't want to rub on the eyepiece surface, because if you have any grit or dirt, that's like putting sandpaper on it, and it's going to grind it into the coatings and begin to eat away at those high-quality coatings that we have on all of our waterproof eyepieces.
So Pekka asks, can the eyepieces be filled with some wavelength-supporting gases like sulfur, oxygen?
I get the question now. I didn't. When you read it, Paul, I understood the question. No, because I guess you could, but those gases are not going to do the same things, because the gases that you're talking about for those wavelengths are actually gases in the wavelength of light. So you can take a spectrum of the light and it breaks it down and it shows you where all the elements are. So it looks like a rainbow, but it has these lines, and either it's emission or, gosh, I can't remember what the other types, but of spectrograph is. But the lines show up where each of these elements glow specifically. So when you energize gases, they glow in very specific narrow wavelengths of light, and you can see those in a spectrograph. And so putting those inert gases into an eyepiece isn't going to help you any, because those gases are not glowing in your eyepiece. They're just in there. They use argon because it's a larger molecule and will not seep out nearly as fast as other, as frankly, nitrogen purged optics will leak out, because nitrogen is a much smaller molecule. Nitrogen has a molecular weight of 3, or a proton weight of 3, and argon is like 32 or something like that on the table of periodic elements. So a much larger, heavier gas, so it won't leak out nearly as quickly. And that's what helps preserve the life of your eyepieces.
He also says if the camera sensor picks up those, then the eye would be able to do the same.
I don't think the camera sensor packet is going to pick up the gas actually in the eyepiece, because it's looking through the eyepiece and there's no energy going into them like in a star where it's being produced, or in a nebula it's being excited by nearby star, or a shock wave, some input of energy. That glass is not going to cause, the gas is not receiving any energy that's going to cause it to actually glow in the eyepiece. And somebody said, "Good evening, Mart. I appreciate it very much." And good evening to whoever that person is. Thank you very much.
Ola Drake.
Oh, Ola Drake. From Germany. We have a very international audience today. Ola Drake from Germany. Good to see you. Thanks for joining us from Germany, where it is late or middle of the evening actually over there now.
Yeah.
So probably it's about 8:30 or 9 o'clock, if I remember correctly, in Germany. What time is it? It's 2:16. It's probably going to be 8, 9, maybe 9 o'clock at night over there. So we appreciate him being up in his evening hours. Pekka, I don't think he says, the gas inside the eyepiece would pick up the better wavelengths. I don't believe that's the case. Not sure, but my instincts tell me that, whatever the gas is in there doesn't really matter, as long as it's a clear gas. And an inert gas, it's not going to do anything other than just transmit light through the eyepiece.
I would think that if the best possible, in my immature and imbecilic opinion, I would believe that the best fill or not fill in the case of this would be to make it a complete vacuum that has no molecules.
You're probably right, but the problem with that is
you'd have to have an eyepiece the size of a truck.
No, you wouldn't have, but it would have to have some really robust seals, because nature hates a vacuum, especially on Earth, right?
So is that why mine keep breaking?
What do you mean?
My vacuums.
It's possible. Very, very possible that could be it. No, nature hates a vacuum. So your thinking is probably pretty good, Paul. If you create an eyepiece with a pure vacuum or very close to vacuum, there's no air in there for it to light refracts.
Yeah.
Through different gases, right, at different angles.
If you put the gas in there, right?
If you know what gas is in there, you know how refractive index it has.
Right.
Right.
And so you would have to have either the lowest refractive index, as you said, or if if there's a gas in there, it doesn't matter. It's going to bump those ions around, right?
But you have to, because of the refractive index of gas, like any surface transition is going to have a different angle, right? And so when it goes into and out of the gas, it's going to have its own specific angle. If you know what's in the eyepiece, then you can engineer the eyepiece to account for that change in direction.
Mostly
right? That change
for it. Because you still got some Heisenberg going on,
But at that point, it's minimizing everything. So being able to know what the refractive index of the gas is allows you to deal with that angle change on the surfaces when light
that's why we stuck
first in and out
telescopes in space, because we don't have a
no
layer
air
of gas
sitting
in the way, causing it to twinkle little star.
Because when you look through the air, you're looking through 78% nitrogen. I think it's 78% nitrogen.
Yeah,
and what we breathe is 78% nitrogen.
Yeah.
So, it's
is it that much?
I'll bet you $1 it's 78%. I'm that confident, or within a fraction of 78. So, between 77 and 79, I'll go there. So,
21% of the air we breathe is oxygen.
Oxygen, right?
So you want nitrogen?
Nitrogen.
Nitrogen.
That's exactly right.
78% of nitrogen and 21% oxygen.
You owe me $1.
I did not bet you.
You rose to the challenge of answering the question. That was accepting the challenge.
No.
So
this
anyway,
was me validating your 78% statement.
So you hear this is getting offline, but off subject, but a little bit. But I gotta say it. I hear car places who do tires advertise that they'll fill your tires with nitrogen. Well, folks, guess what? If you're filling your tires with compressed air, you're filling them with 78% compressed nitrogen.
Yeah.
So, not a whole lot of difference, I don't think. Maybe I'm wrong, but it seems like an advertising gimmick to me. So, let's move along. Talking about a telescope that I don't think we've talked about before. This is the First Light series, which is a series of telescopes, explore scientific design for people who are just getting into the hobby and are curious about it. High quality telescopes at affordable prices. This telescope is over in the carousel for $239.99. It has a generous aperture of 80 millimeters. So this is the AR 80 millimeter, 640 millimeter focal length. Now let me show you this. On 3 places on this telescope, it has a sticker that says, "Don't look at ye old sun." It says in pictograph form, "It'll put your eye out." It also says it back here on the end where the eyepiece goes. There's a little dust plug that goes back there that says, "Don't put your eye out with the sun." And there's also on the hanging part of the focuser, this little worded in about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19 languages saying, don't put your eye out looking at the sun. That's how important it is to not look at the sun unless you know what you're doing. JR says, there is no error. This is the Astronomy matrix. Yes.
Did I misspell something?
No. I think he did. He hit U instead of Y. Astronomy matrix. This is all just a engineered piece of software, and we're actually electrons floating around on the motherboard of some giant computer. So, JR said, nope, I did. He made the typo. So, this telescope comes with a very easy to use Twilight Nano tripod. It just simply moves left, right, and up, down. Now, this literally came out of the box about 20 minutes ago, and it takes a little while. And when I get these nanos, my advice is to just move it around and loosen up that grease a little so it moves a little bit nicer. Now, the left and right is just controlled by the tension down here on this knob. Very easy to use. I'm going to spin the telescope around so you can see it.
Do you want to move it your table to your right and the telescope to your or to your left.
I think
right,
if you go to the if you go to the zoom like it's set up right now, I think it's going to get most of it in there, isn't it?
No, I just get the very end of it.
Yeah, that's what I need right now, because I'm getting ready to try to put the diagonal on here.
There
so
it is.
This is the diagonal. It has a mirror down in here that's right here. Right, so light comes in, bounces off the mirror, and comes out here. This is real simple. It comes in a little plastic wrapper. We're going to put it in there, and we're going to tighten down the 2 keeper screws so it stays in there. There we go. It's tightened down. Now then, the next thing we're going to do is real simple. This is the red dot finder. We'll talk about it in a minute. Putting this together is real simple as well. There's a little groove right here. You unscrew the keeper screw, you slide it in, and you just tighten it back down. That's all there is to it. So I've now put the red dot finder on. Here's the super Plossel 25 millimeter eyepiece. Same thing, unscrew the keeper screw right there, slide the eyepiece in, tighten it down. Now, this telescope, because we've removed the dust cap, is now ready to use, except that the red dot finder is not lined up where the telescope's pointed. So to focus, real simple. You just turn the focus knob. You can see it turning right there. I'm turning the other end of it. And it just extends the draw tube out until you get your target in focus. So to have a good astronomical experience, you need to get your red dot finder lined up with where your telescope's pointing. And this starts with, it has a little plastic piece in there to keep the battery from draining. So you pull the plastic out, turn the red dot finder on. You can do this in the evening, is my piece of advice, because in the evening, you can see the red dot. So the red dot is not a laser beam that shoots out in the sky. It's just a red dot on a piece of plastic inside the red dot finder. And that's what it looks like right there. I think we can get a shot of it through there. That gives us an idea of what it looks like right there. So you've got a red dot that's projecting right here. So it's real simple. Once it's on, you can use this screw to move it left and right, and this little knob to turn it up and down. So you can raise it and lower it. So you put the red dot on the telescope, then find something, the farthest away thing that you can see, a radio tower, a mountain, maybe it's a telephone pole, the top of a church steeple, a minaret, whatever. You find the thing that's the farthest away thing you can see.
We need to make a video on this.
Yeah, we do actually.
Because we talk about it so much,
let's make that a goal for next week.
Yeah, just pop a video in. Now, I'm not going to be here. We're going to have a fill-in.
Lucy's going
to be here for next week, but I won't be here for the week after because I have to go to Dallas.
Tyler and I won't be here on the 21st because we are going to be going to Fort Worth.
The 21st is a Saturday.
Right, we're going to be leaving on the 20th, going to Fort Worth to participate in the Fort Worth Camera Stores Photo Fest on Saturday. It's going to be the first dealer visit we've made in about 3 years since before COVID.
Is this dealer only?
Sir?
Is this dealer only?
What do you mean dealer only?
I can't go?
If you're going to be down there, you can go.
When's it end?
The 21st. It's like 8 to 5 on the 21st.
Just one day?
Yeah. It's a one-day event.
That's a Saturday.
That's a one-day event Saturday. We're going to be down there doing astrophotography and showing people our telescopes with the sun catchers that turned this fantastic telescope into a solar safe observing device. And I'll show you how to do that here in just a minute, actually.
Well, I'm going to be in Dallas on the 24th.
Sorry, not going to be there. Although we'd love to have you if you are.
You would not.
Come down. Get up on the morning.
You and Tyler don't want me in there.
Get up on the morning of the 21st early and come down and spend some extra days in beautiful Dallas, Fort Worth, Texas.
Let me think. No.
Okay. So anyway, what you're going to do is you're going to move the telescope and point it at whatever it is the farthest away you can see, and you're going to get it centered up in the eyepiece right here. And then you're going to look through the red dot finder and move the left, right, up, down buttons until that red dot moves and is on top of, let's say you picked out a tree with a unique shape to it, and you can find it in the eyepiece really, really easy. I like to use things like that on the horizon because they're easy to find. You can follow along the tree line until you get to that spot of a unique, maybe it's an even tree line. There's a tree that humps up like that, so you can use the top of that tree. You put it in the eyepiece, you move the red dot finder to where it's there, and then what you do is you've now got it. Look in the eyepiece, look in the red dot. If they're not lined up, you move the telescope, move it again, get it in the eyepiece, then move the red dot until you're sure both are lined up. Now then, you can pick out anything in the sky. We'll say Arcturus in the evening, or the moon's up now, or any bright Sirius in the western sky. Pick some stars, point it at it, go to the moon, whatever. You simply put the red dot on top of the object and look through the telescope. Now, you're probably not going to be exact because that's really, a mile or two away. Miles are better than yards, okay? 10 miles is better than 1 mile. And then when you find your first object, get it centered up in the eyepiece, and again, fine-tune the red dot finder so the red dot finder matches the telescope. And now the red dot finder is wide field, and it'll get the telescope pointed at your target. Let's see, Ula Drake says, Kent, I remember at the 1980s there was, it was common to screw a sun filter inside of the eyepiece, and I had the luck after I stopped to watch the sun and hear a cracking sound. Absolutely. I don't know of any of those filters that screw into the eyepiece, but better eyepieces. In fact, this Super Plossel has threading. You can take inch-and-a-quarter filters and screw them in here, whether they're a light suppression filter, other filters that are good for visual looking. They used to make a filter that would screw in here, and as Ula Drake points out, very, very thankfully for him to remind me to talk about it, those glass filters are right here. Well, this telescope is sucking in a whole lot of light and focusing it down in it like a magnifier, and right before it comes to focus, it's hitting very close to being in focus. It's hitting that filter. That filter builds up a massive amount of heat, and he says the filter glass was broken. Since this, I watched the sun in the projection modus behind the eyepiece. So, okay, we'll talk about that a little bit. So that filter that screws in here is extremely dangerous for exactly that reason. If you're looking through there and it cracks or shatters, it's not that the glass is going to shatter and come up in your eye. It's the fact that unfiltered, highly focused, highly condensed sunlight is going to come up in your eye, and you are going to, it's just like getting hit by a laser that burns. It's going to make marks on your eyeball. It's going to etch into your eyeball, and you will never be able to see. It could destroy your vision in that eye. That's why you don't want to use those screw-on filters. But what you want to use, now finish up here.
It's like that guy in Armageddon, the movie.
Don't remember it.
He said,
I remember the movie.
You take a firecracker, you set it off in the palm of your hand, you burn your hand. You take the same firecracker, you make a fist around it. Your wife's going to be opening up your pickle jars for the rest of your life.
Yep, that's a great quote. That's exactly like, firecracker in your hand's going to burn you maybe, but you close your hand around it, you don't like your fingers too much attached to your hand, apparently. So this also comes with a smartphone adapter, and how this works is real simple. I'm going to pull off the rubber eyepiece cover. Makes it a little bit easier. I'm going to then set this down on there, just like that. And now, I'm going to spin this over so you can see it. There we go. You can now see that this is set, and I've got to make it a little bit deeper in there. From experience, I know that it needs to be a little bit deeper to make it easier to focus the camera. And now, as you can see, this camera smartphone adapter is attached to the eyepiece. You can turn the camera on, slowly come down in, looking at the camera until the circle of the camera matches up with this, and then you can stick your iPhone to this. Now, my advice is to wet the little suction cups, and also typically verify your case will in fact stick well to it. If it won't, take the case off and put it on just as the phone. And it comes with a very nice elastic strap to help keep it on. I would advise you to go ahead and use a piece of hook and loop of some sort just to make sure, because you don't want your phone to go hitting the ground without a case on it, because then that would be bad, probably for your phone and we don't want that, and I know you don't want that either. Let me get this rubber eyepiece gasket back on there. So this just makes it easy so you can feel it with your eye and know you're close to it. There we go. It's back on there just like it's meant to be. There we go. So spin this around, and I think this is still in the shot. I can move it over a little bit. And that's what's nice about this telescope. It's nice light. It's a great.
It's barely in.
It's barely in. Okay, so here we go. Going to slide the table over and going to bring the telescope in. So
pull it back to you just a little bit.
Pull it back to me.
Yeah. Get it.
There we go.
The inverse square rule is messing with my light. You need to turn it sideways so we can see the side of the telescope.
I'm going to show you how to do it here.
Just like that.
So this is a sun catcher Ula Drake that we sell. This one's just a wee bit too large for this telescope, but the principle is the same, right? The one I have that would fit it probably is in my office. I did not think to grab it as I came, and it's the one that I use when I do solar photography using an ED80. It comes with the cardboard assembled, and then you stick on the double-sided tape, and you stick on these hard black pieces. And as you can see, they all come in a triangle like this to begin with. And so what happens is, then you take your telescope and press it down or set it here, have somebody hold it, and I mark it with a pen or a knife, and then cut inside of it, because you want this to be a nice tight fit. And where this goes is right over the end of the telescope, just like that. And so now, Ula Drake, what you've done is, this is a reflection filter. It also has some substrate that changes the color and filters out sunlight as well. But this filters out all the sunlight, and it never reaches the telescope. Therefore, no heat builds up in the telescope like you experienced back in the 80s. Excuse me, with that glass solar filter. If you find one or buy one on a used site, never use it. Don't use it. Buy it and smash it so nobody else uses it, and save somebody else the danger of using one of those. So if you're just joining us, thank you very much. We have a chat function up. We would love for you to give us a shout out and tell us you're here. There is a, hey Noah, there's a box that's popped up over the chat function, and I can't see it. So could you bring your finger over and run it over the mouse a little bit? That's very weird. Grammarly popped up. Good luck.
That's my Grammarly.
There we go. Lionel Dan Lapousse. Why is the live stream does not have lots of viewers? The viewers view when the viewers view. That's one thing we're trying to basically.
Yeah, so follow us.
If you follow us,
the more followers we get, the more Amazon will tell everybody we're here.
Absolutely. You know, we picked the time at 2 o'clock. I mean, with the strategic reason. It's 3 o'clock on the East Coast, and it's noon on the West Coast. So we know people are taking lunch breaks at noon on the West Coast. 3 o'clock, they're taking their afternoon breaks, which historically are prime times for people to be on live as well. So we've chosen to do it. And, we're in the Central Time Zone. And if we came on at 6 o'clock here, it would be 7 o'clock on the Eastern Time Zone. And it would be 4 o'clock on the West Coast. And, the vast majority of people live on the East Coast and West Coast.
What are you trying to say, Ken?
I'm trying to say we picked the best time slot we could that fit our work schedule and what's going on here. That's what I'm trying to say. So,
okay.
But we appreciate you saying, this is awesome. We appreciate that comment very much for people that love this. And, there's nobody else doing anything like this that we found. And we've searched pretty extensively on Amazon Live. If you're on the Amazon Live homepage, if we were selling makeup or clothes, we might be much higher featured, but
we're selling clothes. Your shirt is in the carousel.
My shirt is in the carousel right now over there for, what's the price of this Habit brand shirt?
$585,000.
No, it's a little bit less, probably $15. I love these shirts. They're vintage back, very nice and cool. Although right now in the studio, let's just say, I wish somebody would turn the air conditioner on, because It's a little warm in here. In fact, I'm
it's
glistening now.
69 in the showroom,
And
here in the studio, it's like 952.
It needs to be about 65 in the studio right now to get the air conditioner running in here. So anyway, moving along. So you've got the solar filter in front of the telescope, Ula Drake. That creates a safe situation where you can look at the sun safely. You definitely want this to have a nice tight fit over the telescope. You don't want a little gust of wind or even a big gust of wind or a little kid to come by and grab it and pull it off without working at it. And by that time, when somebody grabs it and starts pulling off, whoever's got their face in the eyepiece is going to lift up anyway. And, unfiltered sun going into the telescope is not bad for the telescope.
It's just
for
bad
a period
for
of
the
time.
human being.
It's just bad for the human being whose Mark 1 right or Mark 1 left eyeball is at the eyepiece. That's what we want to try and avoid. The sun catchers are over there. They are available in a variety. Stand up. There we go.
I don't want to stand up.
It doesn't want to stand up.
No.
You're
not talking to me?
Oh, yes, you need to stand up too, Paul. Okay. They come in a variety of sizes. You can go on and pick the one for your telescope. If you don't know the size you need, feel free to go to the Amazon.com Explore Scientific store. We will be happy to advise you on which one will turn your telescope, which is great for astronomy at night, into a telescope that can look at the closest star to Earth, which is the sun. And so we can engineer that and tell you need to buy this one and help you make a correct, informed purchase so you're not just guessing about what you're doing. We like to be easy to contact. That's one reason we do these broadcasts every day, is to make it very easy for people to find us and contact us in many easy, straightforward ways. Now, I'm going to do a quick reset here on the stage. So I'm going to step out of the frame, probably for just a few seconds. Back here in the back, I'm going to pull in this telescope, if I can keep from pulling the light over with the cord. I'm going to pull in this telescope. This telescope looks similar to the one we just had, right? Same color, same shape, still on a Twilight Nano tripod, which is simple, left, right, up, down. This is a bigger telescope. It has a 102 millimeter aperture, where the other one had an 80 millimeter aperture. So the bigger the aperture, the more light's gathered in and still squished down in the same circle that goes into your eye. Effectively, the telescope, binoculars, a camera lens, makes your eye the diameter of that lens. In this case, it's 102 millimeters across. If you have a big 8-inch Newtonian, your eyes effectively, your pupil becomes 8 inches across. That lets you see a whole lot more light get focused down into your pupil, and you can see more. And with magnification, you see it closer as well. So very similar telescope in design. It's still a long tube with two pieces of glass up here that start focusing the light down through the telescope into the focuser, bounces through the diagonal, boom, comes up to your eye, and it has a red dot finder on it. You do the same thing we did. Similar telescope. This one has a 640 millimeter focal length, the same as the 8640 we just looked at. So it's going to have the same magnification because it's the same focal length, right? So what's happening is you have the same magnification, but you have significantly more light coming into the telescope. I need to, pi r squared, so we can figure out the math. I'm not going to do that in my head live on TV because you'd see the steam come out my ears. And, the reality is I'd probably have to get Tyler Bowman here and use his fingers to count. And Tyler's a customer service guy. He just walked through and waved. When he heard me say his name, he daddled for the door. So Tyler's not going to be on the broadcast today. I'd like to hoodwink people into coming in. Again, this is the Explore Scientific First Light Series 102 millimeter telescope with a focal length of 640 millimeters. Gathers more light than the previous model. That more light means a little bit brighter image and good contrast for your eyes. If you're just joining us, we'd love for you to give us a shout out here on Amazon Live in the chat function. And if you're on other streams, there's not really any way to contact us. So at Stephen, you have gotten into the right place and right interest. You will never get bothered here or out in the fields. We try not to bother people. We try to help people. We view this as a chance to do education, and that's what I try and do when I'm on here. Andy's new show, which currently is called Fun Day Tuesday, and they're trying to come up with a better name, and whatever they come up with. But Andy is going to start focusing on some of the educational products and toys that we have that are maybe astronomy related, maybe microscope related, may just be fun and other educational things related that we're going to do. But it is we try hard to be educational and inform people about things about astronomy and the way to get started. How do you get started? Go out tonight and just look up. If you've got a pair of binoculars, you've got a pair of excellent tool to start your amateur astronomy voyage. You can look at the moon. You can look at stars. If you live in darker areas where there's not so much light pollution outside of a big city, you can see more. If you're blessed to live where you can see the Milky Way is rising in the morning, and it's going to rise earlier and earlier until this summer we start seeing it in the evening, and it is a spectacular sight up in the sky. Sadly, because of light pollution, which effectively for us is light shining up in the sky for no reason, all that light makes the sky glow, and the beautiful things you could see just 20 years ago or 50 years ago for sure, but even 20 years ago are now dimmer than the brightness of the sky, and you can't see those things. So let me cycle this out. We talked about the mount and the telescope. It's pretty straightforward. Now I'm going to cycle over, not trying to knock over the light by pulling the cord, and we're going to bring in a completely different mount, and this is going to be a polar mount that we're going to show you how to do a polar alignment on. I suspect we got a video that Paul's going to get queued up here in a minute. And
is that what you want me to do?
No, you don't have to, but I figure you're going to. So this is a 114 millimeter Newtonian telescope. So what that means is it has a 114 millimeter diameter, and you can see this thing right here. This is called the spider, and what it does is it holds up a little mirror. So what happens is the light goes down through. This is just an empty hole. This is a tube with, down here in the bottom of the telescope, right here, get it turned where I want it, right here is a mirror. That mirror has a parabolic curve, right? So it's got a curve that when the light hits it, it bounces off towards a point. And that point, now spin this around, so the light is now coming back this way, right? And it runs into, I can do it that way. And it runs into, turn like that. It runs into a mirror that's on the back side of this housing. That mirror reflects the light up into the draw tube, into the focuser. So voila, you are now able to focus the telescope and see things. Now, this has a shorter focal length than either one of the telescopes we just looked at. This has a focal length of 500 millimeters. So it's not going to have quite as much magnification, but it's much bigger around. It's 114 millimeters around, which means it's gathering in more light than previously, the other two telescopes. And more light means you can see dimmer things. You're not going to see them with quite the magnification, but oftentimes they're easier to see when they're small and not magnified so much. And it's a weird thing. People crave magnification. I've been doing this a long time. Most of my viewing is at low power. I don't jack up the power to 500, 600, 1,000 very often. Do I do it sometimes? You betcha I do it when the scene warrants it. And by scene, I mean if the stars aren't twinkling, that means the atmosphere is all the same temperature and density, and the planets and the nebula are going to look great at that level where that sky is just nice and stable. So this comes on an equatorial mount. And what that means is this axis right here, that you can see right here, right there, is pointing either at the north, you have to point it at the north celestial pole or the south celestial pole to make sure that you're pointing in the right spot. Over here on the side is a latitude marker right here, and you want to set the latitude on it, the altitude, to the latitude you are. So here in northwest Arkansas, we're at 36 degrees north, so you simply set it at 36 degrees, and you're going to be real close. You want to make sure the tripod is level and really well down into the ground. And then this telescope, you have to balance. I'm going to show you how to balance this telescope real quick. So if I let go of it, we see it wants to start moving down a little bit, right? And it's rubbing on table 2. This is pretty close to being balanced. If I took it way down here, move this just a little bit. If I take the counterweight all the way down, you see it's going to continue to move. So to balance it, we want to get it to where it just stays and doesn't move, right? And so part of the trouble is it's sticking on this slow motion control I'm going to show you. So that's pretty good right there. I didn't get the thing tightened. Scared me to death right there, it did. But see, I always use the toe saver, which is this right here. This little nut right here keeps it from falling off the counterweight bar. And by not falling off the counterweight bar, it never can fall off the ground and smash your toe. Or if it does fall off, now your telescope's the heaviest thing, and it's going to swing around and go down and hit the tripod. We don't want that. So I've got that balanced that direction. Now I'm going to loosen up this axis and see how it's a little heavy on the front. So I'm simply going to loosen this, and I'm going to move the telescope back a little bit. And that should do it. Yep. There we go. It's going to stay right where I want it. So I've got that pretty well balanced. You don't have to have perfect balance. In fact, I want it to be a little end heavy, and I want it to be a little counterweight heavy, because that keeps these gears in here always engaged. So,
but before you do that,
here goes. It's a beautiful
you
beam
need
footage.
to polar align it correctly.
You need to, well, I get it balanced and then I polar align it, because when I balance, you can do it either way. I just get it balanced first, and then I move the telescope left and right and up and down to get it polar aligned. So by polar align it, you want to point it north. And, you know, it's...
Hints. 3 magic minutes.
You want to run that now? All right, here we go.
That's what I'm trying to lead you into.
I was getting there. You need to know where north is. And if you don't know where north is, there's an easy way to figure it out using a compass and a straight edge or something else that you're going to see right now in Kent's Magic Minute, which is really about 5 minutes long. Yeah. But Kent's Magic Minute sounded better. Here we go. Hey everybody, Kent Marts here from Explore Scientific. Today I'm going to teach you how to polar align your telescope using a broom. Why do you need to polar align? Well, with a telescope that has an equatorial mount, you have to get that equatorial axis lined up with the rotation of the Earth. And to do that, we're going to start with the tripod. We're going to decide which one of these legs is going to point north, and we're going to set the tripod down so that leg is pointed north. First thing I'm going to do is use a level to make sure my tripod is level. So if it's tipped one side or the other, that's going to cause your polar alignment to not be accurate. So we're going to use a level for that purpose. Then we're going to take a compass, and just to make sure that I've got it pointed north, I'm going to use the compass, line up, and go, yep, that looks like it's pointed north. So here's what I'm going to do now. And this is where the broom comes in. The broom becomes a measurement device, if you will. So I'm going to put the broom on the ground with the tip of it right against the north leg of the tripod. And I'm going to back away, and I'm going to use the compass. I'm going to close one eye, and I'm going to use the compass to make sure that the broom is lined up with north, right? And so I can tell I'm off just a little bit. So I'm going to move the tripod just a little bit, and I'm going to turn the broom. And the broom is what I'm seeing that line with to line up. So closing one eye. Now my broom is lined up perfectly to magnetic north. Right here is we're going to talk about something called magnetic declination. The magnetic north is not true north. The difference between true north and magnetic north can be off by as much as 15 or 16 degrees if you live on the east coast or west coast of the United States. Around the world, it varies. And you have to figure out what that is for where you live. Because if you point at magnetic north, you're not going to be pointing at true north. You could be off by 15 degrees. Your go-to will never be accurate. So for this system to work, you have to know what that offset is and be able to program that into your compass. We're going to provide a link to a website and a video that talks about that a whole lot more. Now, we're going to make sure that the tripod is not angled wrong. I'm going to use a small tape measure, and we're simply going to come down here and be careful not to move the broom. And I'm going to measure the distance from the tripod leg to the center of the broom. That is 470 centimeters. That way, it is 470, a little, I'm going to call that good. Actually, I'm going to move the tripod a couple of millimeters, just like that. So now, we know that we're lined up true north with that leg, and these two legs are the equal distance from right here. So it's not pushed that way or that way. So now that we have the tripod with a good alignment to north, we have to put the head on the mount. And that's going to entail this. We're going to be very careful when we do this because we don't want to move the tripod. We're going to put it on and simply screw on the polar head just like this. Remembering everything's going to the north. Now if you're in the southern hemisphere, you're going to do the same thing. You can do the same exact same in the southern hemisphere because it's not polar, it's polar alignment. We just don't use the star Polaris, which we're not using here. This is really good if you can't see Polaris, or if it's daytime and you want to do some solar viewing with a solar safe filter. So the last step of this process is to check the scale of your altitude, right? So we live at 36 degrees north, and I am going to turn the altitude until it gets to 36 degrees north. I'm going to stop. And that's it. With this system, using a broom, a compass, and a tape measure, you can achieve a good, decent starting polar alignment. Personally, I've used this. I've got an amazingly close polar alignment. There's ways that you can use to refine your polar alignment, specifically drift alignment, but it all starts with a good polar alignment. You can do this in the daytime. You can do this in the nighttime if you can't see Polaris. It works all the time. It's a good way to get started learning the process of polar alignment. Isn't that great? I hope you've enjoyed this video. For Explore Scientific, I'm Kent Marts. Get out there and start doing astronomy. And keep looking up. And there you go. A way to use a broom to clean up your polar alignment. Now, it's not going to oftentimes get you a perfect polar alignment, but it's going to get you really close, especially starting out. I can't stress enough for you to understand your magnetic declination. Here in Northwest Arkansas, we're 1 degree west of true north. You get up on the west coast, you get 15, 16 degrees off. So if you use magnetic north, your polar alignment's going to be 15 or 16 degrees off. Same if you get up along the eastern seaboard, it gets as much as 14 and 15, and you're going to have a serious problem because your polar alignment is not good. And polar alignment means this. This axis right here mimics the rotation of the Earth. So if you have a good polar alignment, then you want to point it at something in the sky. We'll say that's right there. So we're pointing at something around the north celestial pole, because remember, in the northern hemisphere, this is the north celestial pole. So we're looking at, say, maybe Mizar and Alcor, a double star that's the next to last star, the handle of the Big Dipper. We're looking at Mizar and Alcor and looking at the double star, which is really turns out to be a triple star system, and that you can see visually. And so if you have a good polar alignment, you can simply turn the right ascension knob right here. I don't think you can see it, so I'm going to spin this around a little bit. And it's not going to work. So You have this slow motion control right here. There, I think you can see it. And you can turn this, and it'll just follow your object all the way around along its nighttime journey. If it starts drifting a little bit in the eyepiece, you just turn it into what's called declination, and just keep doing that until it follows it all the way across the sky. If you have a good polar alignment, that makes it easy for it to track
Gary
across the
Burrell.
sky. I saw that. I was getting ready to jump in on that.
What's the difference between the First Light 114 Reflector and the 114 Explorer 1 Scientific Reflector telescope?
Made out of different materials. The mount is different.
Better.
It has a different. There's no better or worse in mounts per se.
Well,
it doesn't have an equatorial mount. It has a mount that looks sort of similar, but it is a straight alt-az, which means alt, altitude, and azimuth, left and right. So it looks like an equatorial, but it's really much more like the Twilight Nano we showed you before. Besides the mount and color, that's about it. They're both going to have parabolic mirrors.
the mirror quality takes a step up.
Spherical mirrors. Although I believe the quality, as Paul said, the quality of mirror glass is a little bit better.
Yeah.
A little bit better coatings as well.
Plus, you can use 1.25 inch eyepieces.
You still can on the Explorer 1, same thing.
Sure?
Yep. It's going to be, it's 1.25 inch eyepiece. Only those.
Which one is he talking about? Do you know?
The 8030114.
Is it this one right here?
Probably that one right there, yes.
This is the National Geographic version.
National Geographic version. The Explorer 1 tends to be more of a real entry-level educational / toy line. Still a good telescope, but that's the National Geographic version of it. And it has, that one is actually an equatorial mount right there.
Maybe I think it's our only actual equatorial, right?
8820114. Try that. Do you have that one?
I don't list them by that.
Yep.
Then you got this 114 CF,
which is the NT 114 CF. Is just the left, right, up, down.
And again, it's a National Geographic.
Right, National Geographic branded. This one is made out of metal. The Explorer 1 is made out of metal. The mirror is going to be a better mirror. The focuser is a better focuser on the first light.
Way better focuser on the first lights.
If that's what you can afford, Gary Burrell, absolutely buy it. It's not a bad telescope.
No, it's good.
It's just like anything else. If you need a computer, buy the computer you can afford. Buy the biggest, baddest computer you can afford. Now, recognize that every telescope is like a tool. There's tack hammers and brad hammers and roofing and framing and jack and sledge and mallets. They all do a specific job very well. They might be able to do other jobs as well. For instance, I've driven nails with a pipe wrench before. You can do things with telescopes that's not in their wheelhouse, but still works. Refractors, because they tend to have longer focal length, are really good for magnification on things. Newtonians tend to be have a shorter focal length, but much bigger around, so they're good on faint fuzzies. You're not going to magnify them a whole lot, but you're going to get a whole lot of light so you can see them. So each one is a little different.
You're going to have, as you step up, you get rid of the chromatic abrasions and things like that too.
Yeah, chromatic abrasions. So, yes, the abrasions on my right hand from getting hit while umpiring. There I had some very chromatic abrasions on my right wrist.
Come on, that's a thing.
The word is aberration, but yeah, it's close enough.
It doesn't matter. I'm half asleep.
I love the American English, because you can say things like that and just get on their road. They're sort of funny, actually, when I make those goofy mistakes. So, real quick, I want to talk about a very popular item here on Amazon Live is the Explore Scientific 10th anniversary, which was from 2018.
So we do have another question, however.
What do we do?
And the question is, what distance is this telescope good for?
Okay,
The
so
one that you're showing, I think.
you can't really think of telescope as good for distance because, the distances are so vast, what the limiting factor becomes is the sky you have. If you live in New York City or Las Vegas or Los Angeles is blessed with some clear skies because of the clear air coming off the ocean that makes their skies better than, say, New York City or even, various places in the middle of the U.S. If you live in a big city, you have so much light pollution, you can't see the things that are distant, right?
Yeah.
You can't see things that are 90 or 120 million light years away because the sky is brighter than that object and you just can't see it. It's gone from your ability to see. So, they each one do things well, but the limiting factor is the light pollution. So if you live and don't have the ability to travel outside of the big city, you're limited to a certain number of stars and the planets and the moon. Okay, so magnification on the planets and magnification of the moon are where it's at. That would be a refractor. Okay, so like the two we looked at earlier, like the First Light AR 8640 or the AR 102 8640. So 800, I can't say it, 640 millimeter focal length. Boy, I was struggling there. Refractors offer better contrast because you notice the Newtonians and a type of telescope called a Schmidt-Cassegrain or a Maxitov, Cassegrain, have this central obstruction, which reduces the contrast of the blackness of the sky and the brightness of what you're trying to look at. So planets are really good.
Shoot.
Oh, I always do this in the middle of the show. I must be allergic to something in here. Probably
You're
Paul.
allergic to me.
Probably Paul. So refractors are really good for planets. Newtonians are really good for fainter things like nebulas and galaxies, but it all depends on the sky you're going to
So
get.
we've got another question.
Oh, good.
Can you show what telescopes fit the Ixos 100?
Okay, so that's a good question. So
What is the Ixos 100?
the IEXOS-100, which Noah might be able to get up in the carousel so you can see it, is a small go-to tracker mount. So it actually has motors on it that replace these slow motion controls like are on this equatorial mount. And they will, once you have a decent polar alignment, or do a two-star alignment, which builds a mathematical model that accounts for the offset, your error in polar alignment, you can have go-to capability. So it runs off of a Apple iPad, an Android tablet, both of those, and a Windows tablet with a screen of at least 7 inches, or a Windows desktop or laptop computer. It's an app called Explore Stars, which you can download from your app location, and it connects wirelessly to the mount, and then you can control the mount with the device. Now then, it does not run with an iPhone or an Android phone at this time. We're working on an app and hope to have it out later this year. We'd hope to have it out by now, but the mathematics of making very precise communications to tell the mount to move very specific, very, very precise spot in the sky gets to be pretty complicated. And
Are you telling us you can't do the math?
No, I can't do this. I understand what's happening, but it's a specialized skill, and somebody that may be great at putting together games and all sorts of stuff don't necessarily have the skills, the understanding of celestial mechanics.
Hey, do you have the Astro R light, red flashlight?
No, I don't.
Why not?
I didn't bring it off my
That's
desk.
like best practices.
I didn't bring it off my desk. So,
it's in the carousel.
Let's answer the question real quick. Yeah,
Okay.
it's Astro red light flashlights over in the carousel. Let's answer this question. And we're bumping it up against, been going for more than an hour. So the question was, what telescope is good? So for astrophotography, we rate the mount good for 9 pounds of telescope and gear. So a guide scope, a camera, extension tubes, all that stuff. For visual, it's 15, if I remember correctly. So you can have 15 pounds of gear on the mount and it'll still run. Now, if you start getting up, putting an ED80 on it, you're going to have a second counterweight to make it balance correctly. I know JR, if JR is still watching, JR uses a Maxitov Cassegrain that's 180 millimeter aperture. It's running, I think it's 24 pounds, and he's running with 18 or 19 pounds of counterweights on it. He uses that to successfully shoot images of the planets. He would be challenged, I think, to do any deep sky astrophotography, but more and more people that are using the Ixos 100 are finding it's the little mount that can. It was designed to just use a DSLR, digital single lens reflex camera, and a camera lens, and astronomers started going, okay, we can do this, we can do this, we can do this. It's a very flexible system. If you want to wire it hardwired to do astrophotography, which is how we advise to run with a wired cable, because Wi-Fi is, somebody fires up a CB radio or turns on a microwave nearby that's leaking a little bit, can disrupt the Wi-Fi signal. So you don't want that to happen in your astrophotography run. You can run it into the computer. The computer will control the mount. Think of the mount as a robot, right? That's what it is. Instead of a robot that's putting together cars or doing surgery, it's a mount that looks it's a robot that points to the stars. So you can then have a guide scope. A guide scope replaces a finder scope. It looks up in the sky. You find your object. You tell the guide scope to find a star and track it across the sky. And then the guide scope tells the mount where to move to keep pointed at that target. So any telescope for astrophotography based on our limits is going to be an ED80 size telescope. We do sell a First Light 8640 as well. I believe we sell a combination of this telescope and even up to a N130 as well. So a very large Newtonian, 130 millimeter diameter. Takes a couple of counterweights to do that. So those packages are out there as well. Those are for visual. Those are not for astro photography. So I actually use an Ixos 100 all the time. I have been using it for solar outreach. And Saturday at the Salem Springs Farmers Market where we were, 170 people looked through our telescopes. It was a great morning. The Ixos 100, I got it on the sun, did a little fight because it was daylight. I just plopped the mount down and used the compass and a straight edge and got a pretty good polar alignment. I then fine-tuned that polar alignment for 30 minutes, and then the Ixos 100 stayed on the sun without trouble for nearly 3 hours until a 6-year-old girl walked up to it and grabbed a hold of it and moved the whole mount and everything. It was already noon and we were shutting down, so I didn't have to go through that routine again. But it can stay locked on the sun for literally, I've done it for 3, 4, 5 hours with either no adjustments or extremely minor adjustments. So we have reached and exceeded the time limit. I have another show I've got to get ready for in about 45 minutes.
You going to do that in here?
Sure, we can do it in here if you want to.
Okay, so show up early so we can make sure it works.
I understand. So anyway, so that's the plan. Tomorrow we'll be having On the Wing. We'll be talking about binoculars and spotting scopes and birding. And then Friday is Focus on Astrophotography with Tyler Bowman. And then we launch into the standard routine. If you're just now joining us and you like what you're seeing, click that follow button so you get to know what's going on. If you're on social media and want to give us a shout out, like Leonard, I believe, said, this is awesome. Share us with your friends. Tell them we're here so they can come see it either live or on replay, because we get a lot of views on
The mirrors
replay.
are not the same, Gary Burrell.
I didn't think the mirrors are exactly the same.
They're not. There's a different set of qualifications between that particular level of telescope and the first light.
Right.
It's like taking a first light and then comparing it to the biggest, baddest one we got.
Yeah, say a 10-inch truss tube Dobsonian telescope.
Yeah, they're not.
Exactly.
They're not the same. If you're considering getting one, if you can afford either one, it's not going to kill you. I would step up to the first light because there's more. You have a little bit more versatility in the accessories that you can attach to the telescope.
It's got better optic, better mirror, which is the heart of a Newtonian telescope. Better mirror, better focuser, for sure.
Yeah,
and if
you
the
definitely.
But if the money's tight,
Right.
You know, maybe it's a case of wait a little while and buy a better telescope. Or if you're just itching to get started, then consider a pair of binoculars or buy the telescope you're looking at and going down the road.
Exactly.
The trick is to just start doing astronomy. The moon's a fantastic target. With a sun catcher, the sun becomes a fantastic target to safely look at sunspots. It's really cool to see sunspots, but just be sure you know what you're doing. And I see Rosie just popped in and said, hello. Rosie, sorry to tell you, we're getting ready to sign off for the day. I appreciate you jumping in. Rosie followed us, I believe, last week or maybe the week before.
A month or two ago.
It's been a while, and we appreciate her coming back. It's always enjoyable to see names pop up and have become part of our family here at Explore Scientific. We appreciate that very much. So
Howdy,
give
partner.
us a shout out. If there's another specific question you have after we sign off, always
Just send
go
it
over to the Explore Scientific store on
In
Amazon.com.
Right.
So the Amazon.com Explore Scientific store. Click, message the seller and Noah Menard over in, who I've nicknamed Amazon Menard, over in the computer hub where he keeps the Amazon platform updated, processing orders, and handles messages. He'll either get the answer or come find a CSR, customer service rep, to answer that question for you, and we will take care of answering your questions. Bye. I've been on yesterday and the day before. Rosie, we appreciate that very much. We hope you're learning something. And again, share it with your friends. So for Paul Newton,
Paul G. Newton,
who
That's
is
me.
not nicknamed Fig, and for Noah Menard, the rest of the staff here at Explore Scientific.
My nickname
What's your
on the
name?
internet is the Big Fig.
Well, there you go. The Big Fig.
Yep.
There you go. So he is the Big Fig Newton. I'm Kent Marts for Explore Scientific. Thanks for joining us today on Amazon Live, and we will see you tomorrow. And Rosie, we hope to see you tomorrow at 2 o'clock, not at 3:06 or whatever. We appreciate you coming on. That shows loyalty. Thank you very much. Bye-bye, everybody.